SIP, or Session Initiation Protocol, is the latest overnight sensation, 15 years in the making, that promises nothing short of taking your communications flexibility to the next level. Now, to understand why, we need to take a ride in the Wayback Machine to see how things were. The year is 1996. The groundbreaking video game Quake is released, and LAN parties are rejoicing everywhere. Michael Johnson's the fastest man on Earth. And when it comes to telephony, SS7 and H.323 are ruling the public switch telephone network. Oh, times were good. But cracks were starting to appear. These protocols were difficult and time-consuming to develop applications on. For example, call waiting, you know that one, took over a year to develop. The co-developer of Real-Time Protocol, a professor from Columbia University, noticed that in 12 short months, the number of computers on the internet had gone from 1 million to 10 million, and that those long development cycles needed to make a quick exit. What we need, surmised the professor, is an open, flexible, multimedia protocol where applications can be developed in days, not years. But he went on and he said, for this to work, not only does it need to be developer-friendly, but also network administration-friendly. This new protocol needs to reuse common elements of HTTP, DNS, and SMTP. For example, status codes in HTTP, SRV records in DNS, and addressing format MIME extensions in SMTP. And you know what? He did it. SIP was born as the IETF, awarded it RFC 2543 in 1999. Now, updates continued in the IETF until 2001. RFC 3261 signaled that the fundamentals of SIP were now in place and it was ready to be released. RFC 3261 broke SIP down to accomplishing 4 basic tasks: locating users and resolving their SIP address to an IP address, negotiating capabilities and features among all the session participants, changing session parameters during the call, and finally, managing the setup and teardown of all calls for all users in the session. Today, Session Initiation Protocol has never been more popular. So how does all this happen? Well, let's look at some terms. A user agent, the UA, is the end user device that initiates a session. Now, these can be cell phones, PCs, IP phones, things like this. A registrar server is a database with the location of user agents within a domain. It responds to location requests, like phone number and such, from other servers. Now, it probably goes without saying, I would pay close attention to the security on this element. Now, the proxy server is the workhorse. It handles call routing, authentication, and loop detection per domain. It also accepts the initial user agent request to look up information, hence the name proxy. After the call is established, the proxy can stay in path or drop out and allow the user agents to communicate directly. Redirect servers are used by the proxy server if the call is off domain. In fact, in this example, our proxy server, TechWiseTV, will query the redirect server for the IP address of the off-domain user. The redirect server will send that info back to the TechWiseTV proxy server, which will then send the SIP invite to the remote proxy server on another domain. All right, now let's put it all together, and let's make a local on-domain call. In this example, Rob is going to call Jimmy Ray. Now, upon power-up, Rob and Jimmy Ray's user agents are automatically checked in and register their IP address and availability with the SIP proxy server. Now, Rob picks up the phone and dials Jimmy Ray. This in turn sends a SIP invite message to the SIP proxy server. It will then query the SIP registrar server for Jimmy Ray's contact info. After the proxy server receives Jimmy Ray's info, it relays Rob's original SIP invite to Jimmy Ray. Rob's SIP invite is accepted simply by answering the phone. The proxy server informs Rob that Jimmy Ray has accepted his invite and is ready to communicate. Rob and Jimmy Ray now create a direct point-to-point RTP, thanks again, Professor, connection to each other to establish a multimedia channel. Proxy server steps out of the way. The final message is the bye sent to the proxy server, and the session is complete. And that's just the start. SIP has proven to be an extensible and modular protocol that has spawned over 100 RFCs, and its value continues to grow. SIP is also independent of the underlying transport layer, and as such, integrates well with other protocols such as UDP, TCP, LDAP, SDP, RSVP. I could go on. CISCO has authored over 1/3 of the SIP RFCs and chairs many of the SIP working groups to advance development of this exciting protocol. And these are just the fundamentals. This one protocol that can be used to both save money and expand possibilities for your communication needs today.